many people don't like our exponents, and so a long time ago, uh, chemists started having a non-exponent way of expressing proton concentration. It was called pH. Anytime you put P in front of something, it means that you're taking the negative log of that number. So pH means the negative log of proton concentrations. You can also say that proton concentration is equal to the antilog of pH. The antilog means that you just raise 10 to the power of whatever the pH is. This all comes from knowing how to understand logs, that log of 10 to the x just gives you x. So log basically tells you what your exponent is of the 10. So to determine pH from proton concentration, what you need to do is take the negative log of the proton concentration. If you're using a TI-83, the way that you're going to do this is you're going to press the log key first, enter in your number, and then press the parentheses and enter. Notice it will be a negative number. So you can remove the negative, or you can write negative log, put your parentheses and the number in it, and then your number will come out positive. So here's an example. If you do that with 5.9 times 10 to the minus 4, you're going to get 3.23. If you have a calculator that is more primitive than the TI-83 or above, you're going to have to enter in your number first and then press the log key. So if you're not getting correct answers, try that and see if it works better for you. So go ahead and now on your own enter in 4.1 times 10 to the minus 11 and determine what is the pH of a concentration of that for proton concentration. What you should have come up with is 10 to the minus 4 for your proton concentration, for your pH at proton concentration of 4.1 times 10 to the minus 11. To figure hydronium ion concentration from pH, you're going to be using proton concentration is equal to 10 to the minus pH. So if your pH is 2.7, your proton concentration is going to be equal to 10 to the minus 2.7. That will give you that your proton concentration is 0.002. Go ahead and you try it now and determine what is a proton concentration when the pH is 8.8. You should have come up with that it is 1.58 times 10 to the minus 9. So now here are two problems for you to determine on your own. Go ahead and stop and do these problems and then check your answer when you're through. So what is the pH of a solution with a hydronium ion concentration of 8.9 times 10 to the minus 8? You can write down that proton concentration is equal to 8 times 10 to the minus 9. From there, you can take the negative log. So what is the hydronium ion concentration when you have a pH of 2.5? To figure out your proton concentration, you just take 10 to the negative pH. So you enter in 10 to the minus 2.5 on your calculator, and you come up with that your proton concentration is 0.00316. This diagram here shows you how pH, acidity, and basicity is related. First, let's cover neutral conditions. If we're under neutral conditions, your pH is exactly equal to 7, and your proton and hydroxide concentration are exactly equal to 10 to the minus 7. Any slight change in either of these will take you into the acidic or into the basic or alkaline range. If I lower my pH, I'm going to smaller numbers, but my proton concentration is getting larger. So at pH 3, I have a large proton concentration of 10 to the minus 3, but my hydroxide concentration is very small, 10 to the minus 11. If I raise my pH, let's say go to pH 10, my proton concentration is very small, 10 to the minus 10, but my hydroxide concentration is large, 10 to the minus 4. Let's look at an example of how we can relate all these things together. Here's a problem that says, what is the proton concentration, the hydroxide concentration, and the pH of a 3.61 times 10 to the minus 3 molar solution of sodium hydroxide? The first thing that we need to do to figure out anything is we need to know what's going on inside solution. So we take the sodium hydroxide and we know that it's going to separate and give us ions. Because it's 3.61 times 10 to the minus 3 molar, our sodium ion concentration is 3.61 times 10 to the minus 3 molar, and our hydroxide concentration is 3.61 times 10 to the minus 3 molar. Notice that we don't need the sodium ion concentration, it's just there. We do need the hydroxide ion concentration. So let's start with that. Our hydroxide ion concentration will determine our proton concentration. We can write that proton concentration times hydroxide concentration is equal to 1 times 10 to the minus 14. We can rearrange that, and proton concentration is equal to 1 times 10 to the minus 14 divided by hydroxide concentration. If I plug in my value of 3.61 times 10 to the minus 3 into the hydroxide ion place, I will get 1 times 10 to the minus 14 divided by 3.61 times 10 to the minus 3. Entering that in my calculator gives me 2.77 times 10 to the minus 12. I now can take my pH. Now, here's where students sometimes will make an error and they will take a pH of the wrong number. Notice the hydroxide ion concentration is 3.61 times 10 to the minus 3 molar. The proton concentration is 2.77 times 10 to the minus 12. It is proton concentration that we need, not hydroxide concentration. So I take my negative log of the 2.77 times 10 to the minus 12. That will give me 11.6. So my proton concentration is 2.77 times 10 to the minus 12. My hydroxide concentration is 3.61 times 10 to the minus 3. And my pH is 11.6. I've answered all of the questions in this problem.